Alright, so this is course content for 5th or 6th grade science class, and it's on mineral identification, the physical properties we use to identify minerals. Okay. So first we'd start with the definition of a mineral. An easy way to remember the definition is to use the word Finches. F stands for fixed structure. Okay. It never changes, it's always the same. I stands for inorganic, so what makes up the mineral was never living. N stands for naturally occurring, so it's not altered by man in any state. It's found naturally in the environment. C stands for crystalline. This is kind of the most difficult to understand, but it refers to the arrangement of the atoms within the mineral. Okay, it's a very rigid, very organized structure. H stands for homogeneous, so the mineral is the same throughout. And S stands for solid. The mineral has to be in a solid state. So the physical properties we use to identify minerals. Okay, the first one that we look at is luster. Luster, it can either be metallic or non-metallic. If it's metallic, it's going to look like this. Okay, so the mineral is going to have kind of a metal appearance to it. Now be careful, because just because the mineral appears to be metallic, it does not mean it is actually a metal. Okay? If it isn't metallic, we say it's non-metallic. And some descriptive words we use to kind of identify or describe the minerals are vitreous. That means the mineral has a glassy appearance. Pearly, it'll be white. And earthy kind of refers to a dull appearance. So after we look at the luster, we move on to the color of the mineral. Be careful using color. Okay? Obviously, it's the easiest to see, but it's the most unreliable. Okay? And the reason is, here we have two samples of fluorite. One's a candy apple green, the other one's kind of a violet purple. It can also be blue. Okay? So we can't identify the mineral strictly on color because they can have so many different colors out in the field. After color, we move on to hardness. This is the mineral's resistance to scratching. So geologists have created a scale for us. It's called Mohs hardness scale. And it ranks minerals from softest, which is 1 on the scale, to the hardest, which is 10. Okay? So the hardest mineral we see is diamond, and that's a 10, and the softest is talc. Okay? So we use this scale to identify our minerals and see where they fall within this hardness range. So some tools we use to determine the hardness of a mineral, the first and the easiest is our fingernail. So if we scratch a mineral with our fingernail, the hardness of that mineral will be 2.5 or less. If we take a copper wire or a copper penny and we can scratch the mineral, it's going to be 3.5 or less. We can also use a streak plate. Okay, so if the mineral leaves a streak, it's going to be 6.5 or less, the hardness of that mineral. Now, the hardness of this streak plate is 6.5. Okay, so if we get a mineral that's 7, it's not going to leave a streak on the plate. Okay, so if the mineral is harder than the streak plate, we will not see a streak. So that would be quartz or diamond or topaz. All right. Then we move on to the streak itself. This is the color of the mineral's powder that it leaves behind on the streak plate. So we take a mineral, we scratch it on the streak plate, and we see what color it leaves behind. This is the most diagnostic property for metallic minerals. Okay, so they're going to leave a very specific streak on the streak plate. Sometimes it's going to be the same color as the mineral itself, and sometimes it's going to be different. So for example, here we have pyrite. So pyrite looks the same as gold, but an easy way to determine between the two of them is pyrite's going to leave a gray or a black streak on the streak plate, and gold will leave a yellow one. So those are two metallic minerals we have, and we can identify them strictly based on their streak. Okay? And then from there we move on to cleavage. Cleavage is kind of the most difficult to understand, but the definition of cleavage is the mineral's ability to break along planes of weakness. Okay? It's related to the crystal system and how the atoms are arranged within the mineral. So here we have halite. This mineral has cubic cleavage. Okay? So if I were to take a hammer and shatter halite, every single piece that breaks off is going to look exactly like the bigger shape. Okay, it's going to be cubic. So if you look at your table salt really closely, table salt is actually little squares, okay? And it's because of the cleavage within the molecule. So an easy way to see it by eye is if we have a mineral that shines in reflected light on one surface, and there's a parallel surface that also shines, that's going to be cleavage. Alright, so here, like I said, halite has cubic cleavage, so it's got 3 planes. And we also have 1 plane of cleavage. We can have multiple planes, like 6 planes of cleavage. So that's a nice way to kind of help us determine what kind of mineral we have. So a summary here is the definition of mineral. You should be able to remember this fairly easily by using the word Finch's. Okay. On our physical properties, we have luster, which refers to metallic or non-metallic. We have the color, and like I said, it's the most unreliable, so be extremely careful when you use color. Hardness, alright, that's the ability of us to scratch the mineral. So we're going to use our fingernail, the copper wire, and the streak plate to help us determine the hardness. The streak it leaves behind, which is the powder that is left behind on the streak plate. And then last that we just went over, the cleavage. So what I would do is I would have the students break up into groups of 2 or 3 and identify 10 to 15 minerals that they have in front of them and work in groups. That way they can kind of bounce ideas off of each other.